Hey there! In this section of the course, we'll take you through a more detailed introduction to one of the fundamental Python packages used in data analysis, NumPy. The name stands for numeric Python, pointing to the fact that it was created to tackle computational problems. We'll go over what it is, as well as why, when, and how we use it. You have seen glimpses of its applications earlier in the course, so let's build on that. Starting from the what part, NumPy is a package in Python. Other suitable words are library and module, but we'll stick with package for the sake of consistency. This package is a collection of pre-written functions, classes, and methods which are capable of handling and manipulating data and calculating results. The main feature of NumPy is it's easy to use and manipulate arrays. These arrays are a type of data structures which store elements and refer to their values via integer indices. We'll be exploring them in depth in just a few minutes, so don't go anywhere. As for why we use NumPy, it's because the package is incredibly computationally stable and efficient. Because of how stable and ironed out NumPy is, it serves as a basis for many other packages, like SciPy and even Pandas. And while Pandas might be more suitable for storing multiple types of data simultaneously, NumPy is the hands-down favorite when we need to crunch some numbers. Additionally, it works in a lower-level language when computing values, since it has its roots going back to C. This results in shorter computation times, which becomes increasingly important as datasets increase in size. Next comes the when part. We turn to NumPy whenever we want to compute a lot of values for analysis and deal with some abstract ideas like vectors and matrices. Since it's both stable and fast, we can rely on NumPy to estimate statistical values and deal with linear algebra. We can also use it to import data into Python directly and help pre-process it. Furthermore, NumPy is fantastic when it comes to generating random tests. By providing enough arguments, we can create arrays of different size, which means they can contain a different number of elements and fill them with data from a specific statistical distribution, be it a simple one like the uniform and normal, or a more complex alternative like the beta distribution. Alright, we covered the what, the why, and the when, so now it's time to talk about how to exploit NumPy to the fullest. For starters, its biggest asset is its ND array class. On a superficial level, these arrays resemble Python lists because they store ordered data, and we use square brackets to display them. However, unlike lists, arrays are far more useful when it comes to computing mathematical values. This is because array operations work element-wise. If the latter term sounds somewhat unclear, please don't worry. We'll explain it in the next lectures in detail. Apart from that, NumPy is full of useful universal functions and methods designed specifically for working with ND arrays. Unlike general Python functions, they usually compile faster or offer great convenience through two operations we will soon learn about: broadcasting and typecasting. Essentially, if any Python operation has a NumPy equivalent, we prefer the NumPy version because it's tailored towards the data format we're currently using. Of course, further instructions on how to properly use all of these functions, methods, and modules are also available on the NumPy website, www.numpy.org, under Documentation. However, we don't want to run before we can walk, so we'll see how to use the documentation at the end of the section. Before we do that, let's set everything up. In the next lecture, we'll learn how to properly install, update, and import NumPy into Python. Thanks for watching.